Hi everyone. So let's start right now. So I'll be your host today, Jean-Marc Couffin. I'm a senior BIM specialist at BIM One. I've been in this position for the past 3 years. I'm a trained architect, trained in France, in the US a bit, and I got into BIM in 2008. If you want to look for me, you can find me in the Twitter sphere or LinkedIn or in some of the forums for Revit and Dynamo. So just a quick intro about BIM One. We are two sister companies. BIM One Service helped develop BIMTrack at the beginning. In our mission statement, we help organizations to increase productivity and efficiency in their construction projects through digitalization, technologies, and innovation. So we are trying to get building through innovation. And we propose some customized solution for strategy, project, implementation, training, and for architects, general contractors, engineers, and owners as well. We also develop some partnership. We are active in the industry and develop partnership with the trendsetters, best practitioner, and also academic institutions like CAN-BIM, Building Smart, the Grid, and the ETS, École Technique de Montréal, and BIM Group, BIM Québec. So the main topic of the webinar series is understanding geo-referencing. The idea behind the webinar series is to make geo-referencing understandable and lift the curtain on the matter. The series purposed for all AEC professionals. So from the webinar series, you got the first one that happened a month ago. That was about the basics of geo-referencing. The one for today, we'll talk about Revit point clouds and the master file. That's the second webinar. And we'll aim to anchor the knowledge by showing you different concepts, practice in Revit, and recap. And the next one will be on May 26th. And we'll put this knowledge into practice a bit more and dissect the process of setting up a geo-referencing in the rules of the art. So let's get to it. So today's webinar, we'll discuss and explain coordinate systems and points in Revit, how to coordinate coordinates with a master file, and also the origin of point clouds, how to set that up so that it works properly. So if you have any questions or comments, please indicate them in the conversation window in Zoom. So first of all, quick warning, the subject is vast and our goal is to popularize the various themes addressed. So we'll allow ourselves with some simplifications. So coordinate systems and points in Revit. So you all know project base point, survey point, internal origin in Revit, and so on. But the so on is not so obvious. So I'll just explain you first as a reminder of the last webinar, the two systems, how they coexist in Revit. So you first have the project coordinate system, which is the local system. Where am I in the project and where am I on my sheet? So it's basically the sheet oriented to the project north. So you would see your project usually orthogonal like this. And you have the second system, the shared coordinate one, the global system. So it's basically where am I on Earth? And it's based on the orientation of the true north. So I'm looking at the project from the Earth's point of view. You also have in Revit, to set up all these systems, you have 4 Revit points. The first one would be the project base point. It's the part of the project coordinates. It's the origin of the project coordinates. It sets a reference to measure distances and to place elements in the context of the model. You also have the internal origin. That's something that was invisible before Revit 2020. It's something that you cannot move, and it's hard-coded. What you need to understand is that it's the internal origin of the software of Revit. In the second system, in the global system, the shared coordinates, you have the survey point. So it's a master marker on site. It provides you a context to reality on the project site. You also have the origin of the Earth. So this one, not a lot of people get it because you don't see it. It's something that is invisible. It's the origin of the shared coordinates, and we'll demonstrate that in a bit. But what you need to remember from this session is that the Earth's origin is the origin of the global system, and the project base point is the origin of the local system. So how to locate the 4 points in Revit? If you go in visibility graphics, VV or VJ, yeah, 3 of the points are accessible. The missing link is the center of the Earth and the origin of our global system. So if you look at the 4 points, they are superimposed in the default templates. So you see all the 3 first points: internal origin, then the project base point, and then the survey point. And you see them, they are all overlapping in the templates by default, or in all new Revit file that you would create. So I'll show you with a short video how to illustrate the Earth's origin and how it behaves. So to illustrate the invisible point that is the origin of the Earth, we'll work with a survey point unclipped. In Revit, the points are not visible like by default. Like I said, they can be found under the site category. Only the origin of the Earth is not accessible. Initially, they are overlapping on the origin of the Earth in 3 dimensions. So we'll be able to specify the coordinates of the survey point unclipped. And for the example, we'll use an arbitrary coordinates set, 5,000, 5,000, 5,000, just for the example. So you'll see that those 3 points, they remain overlapped, but the coordinates are 5,000, 5,000, 5,000. And this is where the surprise begins when you change the base of the elevation for the levels. Using the project base point, the level is set is at 0 from that point. And from the survey point, you would expect that the level indicates the same distance, the 0, but the origin of the Earth is 5,000 below. So that's how you can show and express the origin of the Earth. The illustration is easier when the survey point is unclipped. We use the same initial file, we specify the coordinates, and there the survey point overlaps on the origin of the Earth, while the base point and internal origin is at 5,000, 5,000, 5,000. And there, looking at the base elevation or the level, the behavior becomes particular. It seems that the survey point is not the origin of the overall system. And it would seem that it's an invisible point, the origin of the Earth, that is this point in particular, this origin. So just a quick note on that. If you specify the coordinates, that leaves the point in place, but move the Earth and project included so that the point displays the correct coordinates. Specifying the coordinates is not the same as entering the coordinates directly in the point, which simply moves the point on Earth. So let me explain also what is a clip. The clipped, when you have something clipped or unclipped in Revit, especially now you have only the survey point capability of clipping. If it's clipped, the relation between the 2 points is locked. So moving the clipped survey point changes the shared coordinate system. To move the survey coordinate system relative to the model, move the clip survey point. If it's unclipped, the relation between the 2 is free. So moving the unclipped survey point does not change the shared coordinate system. To move the survey point to another location in the current survey coordinate system, you will need to move the survey point unclipped. So unclipping doesn't lock the relationship with the origin of the Earth, but always maintains a relationship with it. So 2 things to know. The project base point was unclippable until before Revit 2020, and the unclipped survey point does not lock the relationship with the Earth of the origin of the Earth, but always maintains the relationship with it. So all of this for what? So what we want in the end is to work together between disciplines without having to worry about each file's positioning every week to be sure to discuss a common and lasting basic position. So 2 operating modes are possible to link the models together. The first one is the origin to internal origin. So the origin of origin to origin is the internal origin. origin, yes. But the orientation is defined by the project north. And by shared coordinates, it must be defined beforehand. And the origin of this by shared coordinates is the origin of Earth. But the orientation is defined by the true north. So which one to choose? Origin to origin, nothing should move independently. Envelope versus interior, by discipline, architecture, structure, MEP, building existing projects. And if you go by shared coordinates, building versus site, campus, residential housing, development, models of the same building between them have every interest in being linked origin to origin. Even if they still aim to bring in their shared coordinates closer together on the other end, between the models of the building and the site, it is recommended to link by shared coordinates. We can often start a project by linking origin to internal origin and then switch to by shared coordinates. Afterwards, once the site plan from the surveyor has been received or the position of the building established on the site. So case number 1, working with origin to internal origin placement. You will start your first model by positioning the project base point and internal origin. So you need the intersection between the grid A1 in plan and the level 1 in elevation. And the grids and level will move. We know about it. Nothing serious. Remember that nothing will move independently. So the second step would be to link the models origin to internal origin in all the other models for the same building. Case number 2, by shared coordinates. So linking origin to internal origin implies that the internal origin was the origin of the local system used. To use the global system, allowing us to handle any type of construction project, we'll use the shared coordinate system. So what tools should be used to ensure that the shared coordinates are shared in a perennial manner between the different files? We need a single source of truth. So to share this coordinate system, we'll use a dedicated file, a master file. This will contain all the fixed, essential, and common elements, all the datum of the project, shared coordinates, grids, levels, scope boxes, etc. But we're getting there. So I'll give you now the ingredients and the basic recipe to coordinate coordinates with a master file. So if we take the ingredient, the idea is to show you a safe way to manage the position of your project. The ingredients of the recipe for a geo-referencing that works are a geo-reference surveyor CAD drawings with a single UCS. So that would be the first thing, the first ingredient. An identifiable and permanent geodetic marker to position the survey point on it, and if possible, a data sheet of the marker for future reference. And at least a pair of grids, A1 for example, which even if they are immutable, they are not immutable. They serve as an initial point of reference. We'll choose perfectly perpendicular grids. And the pièce de résistance, a blank non-georeference master file, a blank Revit file with the minimum number of elements possible. It will be shared, so you will want to reduce it to its simplest. So what's the composition of this main ingredient? Like I said, the shared coordinates, you will have the location of the files related to the global system. You'll also have the reference grid of the project and the levels of the project, and also the project models that will be linked in the master file. So the changes required during the life of the project will be made in the master file and distributed to the other models using the copy monitor function in Revit. The simple recipe for beginners, we'll not go through the beginner's recipe, and we'll discuss 3 main points. The first one will be to georeference the master file, and then we'll geo-reference discipline files from the master file. And then finally, we'll just make checks and validations of what we did before by geo-referencing all these files into the master file. So for the advanced recipe, it will be developed in the next webinar. So the first step was to georeference the master file, So we'll get to it. So as a starting point, we have a DWG with two identifiable geodetic markers, one on the property line, the red one, and the other close to the desired location of the project, the green one. In Revit, we start with a blank master file in which we position north and south and east and west grid lines at the intersection of the 4 overlapping points in Revit. And the survey point is unclipped. We insert the DWJ, the CAD file from the survey, center to center. And from there, we want to align the master boundary mark on the property line with the points in Revit and use that as the main point for georeferencing. So we therefore move the CAD on the points of Revit, and we will now select the CAD after that. And once you select it, when you want to select the points, just use the SX shortcut. So you select the CAD file and then you can acquire its coordinates. So we import the CAD coordinate system, and the master file and the CAD file now share the same coordinates in X and Y. The elevation remains to be dealt with. This is a steep slope project. Our marker is 5 meters below level 1, and our desired base point in our project is there. So we need to move the survey point 5 meters down. Then we specify the coordinates in Z with the command specify coordinates, and this point is identified at 1,500 meters in Z in our CAD. And it's possible to enter the unites in Revit. So just remember that you can still put the meter letter back to it. Now the survey point is now in phase with the marker coordinates of the CAD file. The base point is at the exact elevation of our project level, and we now need to identify our shared site correctly. The name of our site should identify the marker ID and the date of the georeferencing. Once you've done that, you're done. You got it. You got your master file georeferenced. Just 3 main notes to it. Very often you would have large coordinates on the CAD file, and that would probably be a problem. So the center to center insertion will allow you to input to put in the DWJ to be positioned not far from the project base point. Also, second point would be to pay attention to unites. Always specify them. Don't use automatic. It rarely works in Revit. Also, the off-axis line correction is something that you don't want to. I mean, you want to keep your lines as they were in your CAD file. And the type of positioning is very important. And last note, you could also use the SX shortcut to properly hook or snap the survey point or any point in Revit. So the main steps for georeferencing the master file. You need to insert the CAD file from the surveyor center to center, and then position the master marker of the CAD file in plan on the survey point unclipped. You can import then the coordinates from the CAD file into the master file, and then position the survey point in elevation relative to the project base point. And finally, specify the coordinates of the survey point according to the coordinates of the master geodetic marker. So now we'll get to the next step. Next step, we have 2 files, one architectural one and a structural one. So we are still in the master file. We still have the red marker, southwest corner, and it's overlapping with the survey point. At the green marker, we have positioned our project base point as well as 2 grid lines to allow us to align our discipline files. We are ready to insert the first discipline file, origin to our internal origin, if the 2 are not too far apart, or you can do it also center to center. I therefore choose the architecture file and set it up to origin to internal origin. And we'll now want to position our model in the right place on site. So do not forget to use the SI keyboard shortcut to be sure to snap properly the intersection of the grid lines. So I use the align and move and rotate commands to align the grid lines of the architecture file with those of the master file, and the architectural model is correctly positioned in X and Y, but not in elevation. Let me make a small pause. So its instance is named automatically, but not properly. Now we'll want to do the same with the structural file. So we'll insert it origin to internal origin, and then we'll do the same. We'll move it to the A1 intersection grid lines in the master file. And again, don't forget to snap shortcuts. Those are your best friends in Revit. So the structural model, once done, is correctly positioned in X and Y, but not in elevation. Its instance is not named properly as well. So now we check the alignment of the model in elevation according to Z and to the desired level in relation to a geodetic marker. And our levels are aligned according to what we have agreed before. So now we'll have to name the instance of the structure file and publish the shared coordinates in the discipline file according to their position in the master file. So you'll need to select the file, and then the link file, then you rename it, and then you can basically publish your coordinates to that file. So it's gonna record the position in the structural file itself. So you need to name the location properly before that. And we'll do the same with the architectural one. So you'll name the link file, the instance of the link file, and then you'll publish by naming properly the site. And then you're almost done. It remains to save the master file and the shared coordinates in all the files, in the architectural one and the structural one. And this will be done only from the master file. So when you hit save for the master file, it will ask you to save for the architectural one and the structural one. Let me hit pause again. There's a final precaution. You might want to unshare the coordinates before exiting the master file to avoid moving the shared coordinates. So we tie up the coordinates from the linked files. So if they are to be moved, that could be easily be moved back to their geo-reference location using the move instance to command. So the last spot that we'll need to address would be the checks, the validation. So now we'll open the architectural file. And then we'll check that the project base point and survey point, they don't seem to have moved. So we'll check the shared site. It's the one that we've created, so that should be correct. And we also need to check that everything is fine. We are going to insert the master file in its shared location. So we add the master file, select it by shared coordinates. And then you'll see that the view is oriented to the project north. So if you look at it, you see it's oriented accordingly to the project itself, but not according to the geographic north. So switching to that one, you can see that the relation between the two seems correct. And to follow the logic of the master file and the points in Revit, we place the unclipped survey point on the geodetic marker on the property line in all 3 dimensions. And you'll see that it's matching the coordinates. So we go in elevation and check it as well. We can validate that it's correct in elevation. And then after that, final validation will be to insert the structural file in the architectural one at the shared location. And you can see that everything seems fine. So moving the survey point and the validation moving the survey point is something important, and you will need to make this validation in the structure file as well. So meaning inserting by shared coordinates the master file and also the architectural one. Better safe than sorry. So to sum that up, here are the main steps to georeference the files from the master file. So you would have to link the file that you want to geo-reference center to center or origin to internal origin in the master file, and then position the linked file according to the desired location and orientation in the master file. Then you will need to publish the coordinates of the linked file to its source file, and then disable the linked file shared site, except for BIM 360 files, obviously, and then check the geo-referencing by opening the linked file and inserting the master file at its shared location, and not forgetting to put the survey point accordingly. So the last step of the presentation is going to be talking about the point cloud's origin, or how to work in local coordinates. For the point clouds in Revit, you have three options to position, to insert the point clouds. The first one is center to center. It's not very practical for real positioning. The other one is origin to internal origin. So the point cloud should be geo-referenced, therefore not in relation to the internal origin of Revit. So that wouldn't be useful at first. And the last option would be by shared coordinates, which probably will be a problem because you have big coordinates, which implies dancing lines and difficulty to snap to the point clouds, which kind of misses the point. And anyway, that the shared coordinates do not mean that the point clouds and the Revit file do share the exact same ones. So what shall we do? We could work in the local system. For this, the origin of our point cloud will have to match the internal origin of Revit, and it will be necessary to adjust the origin of the point cloud. It's always possible to modify and restore the origin of a point cloud afterwards. The issue of the point clouds that are not displayed correctly is still relevant today and depends on several factors. Two of those are that your internal origin might be off from one file to the other, and the other one is the performance of your workstation. And the risk is therefore that to have inconsistent display of the point cloud from one workstation to another, and from one file to another. So working in local coordinates, the preferred method in recap, it's possible to enter the coordinates of the origin and its rotation manually. So according to the three plans, X, Y, YZ, XZ, the adjustments are very simple. But it must be rigorous, mastered, and especially, I insist on that, documented. Keep notes of what you're doing. The option to restore the origin is always available, but we'll have to establish the coordinates of our internal origin in Revit to position it in recap and use it as the origin of our point cloud. So after having specified its origin in recap, the placement origin to internal origin is perfect. It's easy, and you will see that you can snap on every point of the point cloud easily. The adjustment can be manual if needed, as long as a common point and common master marker exist between the model and the point cloud. So that concludes today's webinar. And on May 26th, we'll go through the same recipe, but in much greater details. We'll show you how to create the perfect master file. In greater detail, also we'll show you how to geo-reference the master file and how to geo-reference other models in the master file shared coordinates. This way we'll provide you with the most efficient and detailed geo-referencing process. So if you have any question, please, or comments, you can still send them to info@bimone.com. And thanks for joining me today. Bye-bye.